Yeah.
So we're going to be continuing our discussion in the scientific method, and now we're at the results section. So one thing to keep in mind, when you give out results, you need to put units in front of them, otherwise the numbers don't mean a thing. Work with me here. So, for example, if I write, pounds, say, inches, seconds, just keep it really simple. Work with this here. Okay. Yeah. Well, so if you look at pounds and there's a number in front of it, what does that tell you, if anything? Anyone can answer. Denai, you want to take a shot at it? Pounds. If I say, if you look at something, if it's something like 86 pounds, what does that tell you?
Well, it indicates me weight.
Exactly.
Because I know what that is.
Mm-hmm. Pounds are a unit of weight. So, and then next, inches. Inches are a unit of
measurement.
Again, but what kind of measurement?
Distance.
Distance, exactly. Distance or length. Seconds is a measurement of time. So we have different units to tell us different things, and without any form of unit after it, the number doesn't mean a thing. So if I write the number 5 for a scientific measurement, that tells us nothing. But if I say 5 inches, 5 seconds, 5 degrees Fahrenheit, that gives us some answer. So with that, here in the US, we use what's called the standard system, and you know this, inches, pounds, what we've done. But in science and in every other country in the world, we use the metric system. And here, you're going to ask me, why do we use the metric system? Why we have to use it? It makes no sense. So to kind of to debunk that a little bit, we'll do just a little quick exercise. So we're going to start from inches to feet to yards for now. So how many inches to a foot? 12. There we go. How many feet to a yard? 30. Here's where we get fun. How many yards to a mile?
5,280.
That's feet, close.
Oh, wow.
It is actually 1,780. Wow. And for fun, if you want to go the other way, it is 0.000586 miles to a yard. Go figure. So this is the standard system. This is what we work with here. This doesn't make sense at all. They're completely arbitrary. But let's take that a step further. Let's go to the metric system. So let's start with millimeters. And then centimeters, meters, and of course, kilometers. I don't know why the pronunciation changes. It does. I teach science, not English. So, millimeters to centimeters. Off the top of your head, for what you know.
10.
10. There we go. Good enough. Centimeters to meters. 100. And lastly, meters to kilometers. 1,000. So, looking at the two columns of numbers here, what is distinctly different about this column versus this column? The first observation that pops in your head.
There's some sort of pattern inside.
Mm-hmm. And what's the pattern?
Increases by 10.
Yeah.
You multiply by 10 every
Yeah.
time you go.
Some power of 10, right? So, for example, in between centimeters and meters, there's decimeters. And that centimeters to decimeters is 10 decimeters to a meter. That's the metric system. Everything increases, there's a unit for every power of 10 to a certain degree. Whereas for standard units or English units, it goes 12 inches to a foot, 3 to a yard, and then for no reason whatsoever, 1,780 yards to a mile. So that's the reason why we really do not use this in science. It's confusing and it makes conversions to do impossible. So for example, how many yards are in 4.2 miles? I have no idea, you have no idea. But if I gave you 4.2 kilometers, how many meters are in that? Yep.
4,200.
Exactly. You can do that right off the top of your head, doesn't require a whole lot of effort, and it makes the other stuff in science so much easier to do. Now, fun little story. In 1999, NASA launched a space probe, and there were two laboratories coordinating, one in Denver, one in Pasadena. And luckily enough, the Denver lab did the calculations in feet, while the Rocket Propulsion Lab in Pasadena did programmed the rover in meters. So what was supposed to go 350,000 kilometers went 350,000 feet, and as a result, they lost a $125 million spacecraft because they used the standard system and no one knew what was going on. It's because for this reason that everyone in science adheres to these, and these are completely arbitrary. These numbers make some sort of factual sense. They go by the powers of 10, and you can save a lot of time doing these calculations because you can go easily from one way to the other. It's all in powers of 10, whereas here, 1,780 to 0.000586. It's a harder thing to do. So now to the more entertaining portion of our lesson. We get to stand up and we get to do a little two-liner. So everybody up, like it or not. Come on, work with me here. So, to get you into the habit of using the metric system when we're in a scientific setting, we're going to do two quick lines of the metric slide, which you can guess is a parody of the electric slide. So it goes like this. In the metric system, we convert by factors of 10. And when you use, the fun with metric will never end. Ready? So if you want,
Do a sing along.
hey, you gotta sing along with me now. Ready?
Let's go.
5, 6, 7, 8. In the metric system, we convert by the powers of 10.
Convert by the powers of 10.
And when you use, the fun with metric systems never end.
Never